for sequences in series. The definition of a sequence is an ordered list or an ordered set of numbers. Remember, order is not important. It can be finite or infinite with dots. So here's an example. We want you to find the first 5 terms of the sequence, assuming that n equals 1. So here is our equation, and we're going to go ahead and plug in 1 into the equation for n. So 5 times 1 minus 3. Simplify it. 5 times 1 is 5, minus 3 is 2. So our first term, a1, is 2. Now we're going to go ahead and plug in 2. So a sub 2, plug in 2. 5 times 2 is 10, minus 3 is 7. So a2, the second term in the sequence, is 7. Now we'll go to the third one. 5 times 3 minus 3, 15 minus 3 is 12. More left. A4, 5 times 4 minus 3, 20 minus 3 is 17. Last one. A5, 5 times 5 minus 3, 25 minus 3 is 22. So now we go ahead and list our sequence. Commas in between. The last term was 22. The next one is 17, 12. I'm just kind of going backwards in order here. And then 7 and 2. Later on, we're going to teach you about the arithmetic sequence. But this is how you find a term or a set of terms in a sequence. All right, here's another example. We're wanting you to find the 11th term in a sequence. So here's our equation. We're going to go ahead and substitute 11 in for n. All right, so now we do our orders of operations. So we're going to go ahead and put 44 in the numerator. 11 times 11 is 121. 2 times 121 is 142 minus 4, 44, 138, and then just go ahead and reduce that down, and you'll get your answer. Next thing is factorials. Factorials you've learned in Algebra 1, Algebra 2. It has a notation that looks like this, n factorial, and what it means is whatever your n is, you go down to that value of 1. So I'm not the biggest fan of going from 1 to the highest. I like to write it like this instead. So if you see 5 factorial, I say 5 factorials, I start with the highest number, and I drop down to 1. And you multiply those numbers together and you get 120. All right, so here's an example. We want to find the first 5 terms of this factorial. So we substitute, in this case, 0 for n. So a0, 2 to the 0, 0 factorial. If you remember, if we go back here, 0 factorial is 1. Anything raised to the 0 power is 1, so 1 over 1 is 1. Substitute 1 in, 2 to the 1, 1 factorial, 2 to the 1 is 2. If you head back here, 1 factorial is 1. All right, we'll continue on up to 5 terms. So then a2 is 2 squared, 2 factorial. 2 times 2 is 4. 2 factorial means 2 times 1. 2 times 1 is 2. Simplify it, and you get 2. A3, 2 cubed, 3 factorial. 2 times 2 times 2 is 8. 3 factorial represents 3 times 2 times 1. 8 over 6 reduces to 4/3. Last term. This is the 5th term, 2 to the 4th, 4 factorial, 2 to the 4th is 2 2 times 2 times 2 is 16. 4 factorials, 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. You can reduce this by 4. So this is a 4. Hope you can reduce it by 8. 2 and 3. So now we list out the pattern, or the sequence. I'm just going backwards on my smartboard here. Last term was 2/3. Next one was 4/3. 2, 2, and 1. 2, 2, 1. So here is our sequence. Let's do a couple more problems of factorials here. If you have 8 factorial, what 8 factorial represents is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm going to show you a little trick here. Now we do 2 factorial. That's 2 times 1. Now 6 factorial. Isn't this the same thing as these 6 terms and these 6 terms? So if they're dividing each other, I can go ahead and cancel those out. So now I just have 8 times 7 is 56 divided by 2. Okay. All right, this one, let's quickly reduce that one also. All right, so now we have 2 factorial, it's 2 times 1. 6 factorial is 6 times 5. I am stopping at 5 factorial because I have a 5 in the denominator. Now I have 3 times 2 times 1. All right, these two guys cancel out, right? 5 factorial and 5 factorial. Now these two cancel out because 3 times 2 is 6, and I have a 6 in the numerator. So I'm left with 2 over 1, which is 2.